Hello again, class. We are picking up where we left off in terms of z-scores. In this video lesson, we want to calculate the proportion of records that are plus or minus 1, 2, or 3 standard deviations around the mean, and how that relates to the empirical rule. Now, just so you know, the empirical rule states that 68% of your cases should be plus or minus 1 standard deviation around the mean. 95% are going to be plus or minus 2 standard deviations, and 99.7% are going to be plus or minus 3 standard deviations. In this example, these are SAT scores. They have a mean of 490 and a standard deviation of 100. So you can see where each of these lines corresponds to where these standard deviation cutoffs are. Just one other thing about the empirical rule and the normal distribution is technically these tails on the left and the right side do not touch each other. Although while the percentage is 99.7% for plus or minus 3 standard deviations, theoretically the normal distribution goes on forever. So in later lessons we may be talking about 6 sigma, if you've heard of that before. 6 sigma says that there are 6 standard deviations plus or minus around the mean. So just a little hint there. So how do we calculate these percentage of cases for these z-scores that are plus or minus 1, 2, or 3 standard deviations around the mean? Well, we're going to go to our handy dandy data analysis tool pack. We're going to go to our descriptive statistics. We're going to select our z-score column. We're going to run our summary statistics, click OK, and there they are. Now I already have these copy and pasted over here. Now the only thing that's of value to us here is the minimum and maximum. What this is saying is that on the low end, we have cases going out to minus 0.99 standard deviations, but then we have on the right side of the distribution, a majority of our cases are going towards up to 6.64 standard deviations. So we already know basically that our data is not congruent with the empirical rule because the left side of our distribution doesn't even go past minus 1, and it's going past positive 3. And we're going to use this information to create our bin ranges so that we can calculate our frequencies real quick and easy. So if you recall from a prior video lesson on how to create ranges off of continuous data, we're going to go to our data analysis tool pack, click on histogram, click OK. We have our z-score data selected, and then we have our bin range selected. And here you'll see I have this going from minus 3 to 7. Now the minus 3 is there to account for our initial question in terms of asking us about how many are plus or minus 1, 2, or 3 standard deviations above or below the mean. But I exceeded 3 standard deviations here because we have a maximum range here of z-scores going up to 6.64. I hope that makes sense. So we are going to click OK, and there is our frequency distribution. The only thing that's missing here, if you recall, is the actual individual frequency percents for each range. So to calculate those, now these bins are actually representing standard deviation ranges, and these are the end of the range. Okay, so we are also going to need to calculate the total here, and to check our math, there should be 1080 cases here. So we're good. We know we collected all the data. Now the frequency here obviously is just this number divided by the total and then expressed as a percent. So we're going to do this, put our equal sign, grab that first figure, divide it by the total. Now if you remember, the total needs to stay the same for every equation. So we're going to click in front of the B in B12, press F4, and hit enter. Obviously we know that's 0. And just drag this down. And there are our frequency percentages. Now obviously it would be nice to clean this up. We'll change these to percents by clicking the percent key. And let's add some decimal points to that by formatting this percentage and adding 2 decimal places. So there are our percentage of cases in standard deviations. Now, to answer the question, how many are plus or minus 1, 2, or 3 standard deviations? So to do that, we'll just make this nice and clean. We need to know how many are plus or minus 1, how many are plus or minus 2, and how many are plus or minus 3 standard deviations. So this is simply we're just going to add up our frequencies according to these ranges. So plus or minus 1 is simply the sum of minus 1 to plus 1. So there's your first answer, 85.65%. Now, for minus 2 to plus 2, we're just simply going to add that range. So we're going to go minus 2 to plus 2. Close the parens. There we have it. And how many are minus 3 to plus 3? Well, again, this is just some simple addition. We're going to go minus 3 to plus 3. So there are our percentages. 85.65% are minus 1 to plus 1 standard deviations. 94.72% of the cases are minus 2 standard deviations to positive 2 standard deviations, and 98.6% are minus 3 to positive 3 standard deviations. Now, the second part of your question is asking you to compare and contrast that to the empirical rule. Well, the empirical rule, if you remember, stated that 68% are supposed to be plus or minus 1 to plus 1, 95 are minus 2 to plus 2, and 99.7 are minus 3 to plus 3 standard deviations. Well, what do our data look like? Well, this doesn't look anything remotely close to 68%. This is somewhat close to 95%, and this is just shy of 99.7%. But in general, when looking at the overall frequency, this is majorly skewed to the right. And that's what you should get out of this. Alright, this concludes another video lesson. Have a great day.